This video explains how to work with ad hoc file formats, looking at the behavioral responses and the statistics of those behavioral responses when the files are consumed by a variety of parsers. You can get the tools from our GitHub repo. Because they're basically a fairly straightforward R library that's not even really built as an R library. It's just a bunch of files that you can include and work with. All right, so we've got the repo down. Let's go switch over to RStudio and show you how to use it. Okay, so in the repo there are several different R files. You want either the CSV demo or the NITIF demo to play with. I'll start with the CSV demo, which is a little simpler. Make sure to set your source working directory to the source file location, and you can start running. So this requires tidyverse and igraph, but we can get the data loaded in. The data consists of a table of a variety of files. Each row is a file. Each column is a kind of message, except for the first one, which is identifying the files. So you can see that there are some delimiter messages, some quote messages, etc. Each of these are categorical variables. And it is convenient to turn this into what is called a tidy format, wherein each row is an observation of a particular message. So the difference between these two is a pivot. This one is the original data and has been pivoted longer. Let's have a look at what the data look like, just as a summary. Frequently, we've shown this as a relation matrix. Each column is a file. Each row is a particular message. And everywhere where there's gray, that file does not exhibit that message. Otherwise, you can see a count for how many files exhibit that message. It's a count because, of course, there's some aliasing with 3,000 files. Okay, great. We can render this into what we've been calling a Dowker table, which captures the message patterns. There we go, there's the Dowker table. And so the feature pattern tells you what the encodings are, or what the messages are. So for instance, this first row consists of tab-separated quote, double quote containing ASCII files. The observations shows you which files, so these are 2 files, and the weight says there are 2 of them, and you can see there are 3 different features or messages. This is a much more common pattern. There's a lot of files that you could see exhibit that. If you're interested, you could double click on that and see them all. And there are 2 messages involved. There's the comma and the ASCII message, and so on. There's lots of different message patterns, as you can see. Okay, going back to our data. In order to find dialects, we need to render this into a graph representation, which is very similar to BAE's Dowker graph rendering tool. This is just an implementation of that in R. It's fairly quick for something small like this. And then the max decreasing decomp finds the dialects. So this takes a moment or 2 to run, not very long, and produces some output in a tabular format. Again, the feature pattern. So for instance, this 1417 should be familiar from the previous instance, which is the comma-separated ASCII files. Of them, 1,388 files exhibited that particular pattern and were not explainable by way of just ASCII files. The dialects, of course, the system doesn't know what they mean, and so merely gives them integer labels. So you can see the breakdown. These are file counts in each of the different dialects. So it looks like there's 2 different dialects that exhibit this particular feature pattern, the comma and ASCII. And actually the first one is looks like tab, quote, and ASCII. The second one here is looks like comma, double quote, and ASCII. And you can see the breakdown is sort of spread out across several different dialects. So of course this is now the place where you want to dig through each of these and try to interpret what they mean. All right, it's kind of hard to see that tabular format, perhaps, so it's good to get a nice graph visualization. So this is what uses the igraph graph rendering tool. So these little blocks of code prepare the igraph data and get it labeled, and then the TK plot brings it up as a plot. This is not necessarily an easy plot to look at because everyone's on top of each other, but fortunately if you say layout and play around with these different layouts, you can get a nice layout. So for instance, this blob here is all the ASCII files. The size of the vertices tells you roughly how many files are implicated. So you can see the ASCII alone files, there's some of them, but there's a lot more comma ASCII files, as perhaps you might imagine, seeing as this is CSV data. And then you can see that there's a variety of others that are unrelated. So here's a separate dialect that involves the ISO 8859-1 encoding. So this is the CSV example, and it gives you a nice idea of what you should be looking for. But of course, this could be much richer. So let's head over and play with. Let me close these tabs out. Let's play with the NIDIF dialect as well. Okay. So let me open the NIDIF demo. Same kind of thing going on here. We've already set the source directory, so let's go load everything. Most of these are the same. Bringing in the data, there's a variety of data from BAE systems and a different set of data from one of our exercises. So this is all data prep and cleaning, just to give you an idea of what it looks like. Now, the tidied up data include a file index, an error index, regular expressions, and a whole bunch of rich metadata associated with that. Here's a rendering as a relation matrix. Here's a rendering of a different relation matrix for the same kind of files. One of the capabilities that we've used over the years has been the principal components analysis plots. So here's a principal components analysis plot. You can see it's in 3 dimensions with the sources of the files labeled by color. The previous plot as well. Let's see here. Let me render this guy over here for you. The BAE plot is a little different. So you can see that there's some definite clustering and structure going on that might be worth examining. I'm going to skip ahead a bit to the Dowker tables construction. They construct fairly quickly. If you're interested in Dowker histograms, those we had used thresholding early on in the SafeDocs program. Here's a breakdown of how many different files exhibit which feature patterns versus their sources. So you can see that some sources generate very distinct sets of feature patterns, whereas others generate different ones. Same kind of thing going on over here as well. You can mess with the print formatting to change how many of these different rows and columns render, just so you can have an idea. But you can see that, for instance, the mutator generates a whole bunch of patterns that are somewhat different from the imaging NIDIF set. If you want to go ahead and say, given a certain pattern of behavior, what's the probability you came from a different source? It's basically re-rendering the same data, but probabilistically. You can do that as well. And similarly for the other regular expression set. So, for instance, if you see this feature pattern here, whatever that happens to mean, 100% chance it came from the TNG set. Okay, cool. Again, we can go ahead and build the graphs. For the crashes version, this is fairly quick, and we get a nice summary table out. Again, the automatic dialect generator doesn't know what to call the dialects. That's your job as a human. But you can see that dialect 1 basically is all of these guys, whereas dialect 2 is rather different, and so is dialect 3. So the different dialects are partitioning off these behaviors accordingly. This can take a bit longer to run. This particular one, if you use the BAE regex set, which is much larger, the rendering time is, well, about 2 minutes or so. I'm going to pause and restart the video to skip that. Okay, so that's finished. So now we will go build the dialects, which doesn't take very long. Now that the graph has been built, the graph is really the slow part of the process, and we can get similarly a dialect summary as well. The remaining code tries to tie the dialects to the source metadata. It turns out there is not a strong correlation, so I'll end the video here and hope that this sort of tools might be useful to you.